No, going to continue to record. Okay, good. All right, so let's type this in. We're going to do sine of cos inverse of x. So let's see if we get this. So what sort of graph do we get? So what you do is you type this in, and then, yeah. All right, so what shape does it give you? It looks like it gives you a semicircle, isn't it? And the question is, why does it give you a semicircle? We're not going to do a table of values. We're going to prove it. Why do we get a semicircle? So if I draw this, it's going to look like this. Radius of 1. And you can do the same thing with the other one as well. Let's see if you also get a semicircle. So I just make this small so you can see the other graph. So you can type another thing again. So copy this and paste this and write cos instead. Let's remove that. Change that to cos and then change that to sine. Yep, also give you a semicircle. So this one or this one, they both give you a semicircle of radius 1. Okay, so let's see why we get a semicircle. Okay, oops. We'll go like this. 1. Okay, good. So we got that. Now what we do is we're going to prove it, why it's a semicircle. So that will give you a proof. So let's prove that. To prove this, let's start with y equal to sine cos inverse of x. So we're going to let theta equal to cos inverse of x, which means cos theta equal to x. So that's the first step you do. And then what you do is we're going to write this down. This is equal to y equal to sine theta, because this is theta, isn't it? Theta is cos inverse of x. And then what do? We're going to draw a triangle. So y equal to sine theta, cos theta equal to x. Therefore, you can get rid of sine theta and cos theta, isn't it? You can go x squared plus y squared equals to cos squared plus sine squared. And what's cos squared plus sine squared? You get 1. So you get a semicircle. But why do we get semicircle, not a circle? If you make y the subject, you get 1 minus x squared. And then we have to think why this is the case. Oh, that's right. So if you look at this thing, cos theta, cos inverse of x. Now, what's the range of cos inverse? No, that's the domain between 0 and pi, isn't it, in the first two quadrants? And in the first two quadrants, sine is positive in the first two quadrants, which makes y positive. Y is positive. So that means you only get the upper semicircle, right? Not the lower half. So when you square root it, you just get y equal to this, because y is positive. So that's why you get the upper semicircle. Alright, so that's the proof. So now you can see, just remember when you got sine, cos inverse, when they're different, you get a semicircle. And you do the same proof with the other one, which I won't go through. We'll just do revision today. Yeah. Okay, good. Yeah, so all the answers after this page are provided for the graph, so you can just do it yourself. All the answers are provided. The sine inverse of sine is this. Cos inverse of cos. They're all zigzag like this. With the tan inverse tan, there's a problem. So this is an open circle, not a dark circle. I think they're all open circle, like that. So that should be, yeah, open circle. Should be open circle. Okay. All right, what else are there? And you notice that if I do the next bit, sine inverse cos, it still gets zigzag, right? If I put different things together, they will get zigzag. And cos inverse of sine, you also get zigzag. Or sine inverse, cos inverse is limited in the domain between 1 and -1. But if you put a cos inverse with a sine, you get a semicircle. And then tan inverse is a straight line. Okay, so we did an overview of all the graph, and then we'll do a summary. So we're on page 27. How come it's different? See another page before that? Did I lose it? Okay. I must have lost the page. It should be a graph after this, right? It should be a graph after this. I lost the page. It got moved. So let's move it back here. That's right now. That's page 27. Okay, let's look at, so now we're going to do a summary of all the graph. So starting with the sine inverse. Okay, so let's make it like this. Okay, so we can draw the sine inverse graph. The domain is between 1 and -1. Range is between ∅2 and −∅2. So you get 1 here, -1, ∅2, -∅2. Notice that the range is a bit higher, 50% longer than the domain, because ∅2 is about 1.5. X and Y axis are labeled, and then what you do is plot 3 points. And you get then you draw a line, draw a graph like this. So vertical tangent, and then like this, and then vertical tangent again. Okay? So there's vertical. Right, sine inverse done, and then do the cos inverse and the tan inverse. Right, after you're done, do the cos inverse. Domain x between -1 and 1, and range is y is between 0 and pi. 0, 1, -1. And then it's going to get squashed. It starts from the top, goes to the middle. And then goes here. Oops. Let's see. Vertical tangent, go down, and then go vertical tangent. Alright, so cos inverse graph is drawn, and then do the tan inverse. Alright, have a think. Do the tan inverse. Okay, tan inverse is all real x, and then range is between ∅2 and -∅2, but not equal to ∅2. So there are two asymptotes, ∅2, -∅2. And then you put x there, put y there, and put 0. At 1, it's exactly halfway, ∅4. So it goes like this. Okay. Alright, that's your graph. So it's concave up, 0 is the point inflection, and then concave down. Alright, all done. All three graphs are done. You need to memorize all 3 graphs, then we can use it to do many questions. We're going to do this question. Find exact values, so all you have to do, just let this equal to theta, so let theta equal to cos inverse of -3/4, and then you just write down cos theta equals to -3/4. The negative means that theta is in the second quadrant, theta in second quad, right? So when you draw the triangle with the theta label, then you got 3/4 adjacent over hypotenuse. Use Pythagoras to work out the third side, 16 minus 9, which is 7. So root 7. And then you work this out. So therefore, this can be written as tan theta, because theta is cos inverse. Tan theta in the second quadrant is negative, because it's in the second. Negative. Negative root 7 over 3. Like that. Opposite over adjacent. Alright, that's done. Make sure you learn this because that's important. This can be examinable. And then we also did the other one, inverse trigonometric identities. Some of this. So these 4 need to know how to prove it. Need to know the proof. And remember, this can be done in 3 different ways. 3 ways. Yeah. Okay, so 3 ways. So we can do it using derivative. Actually, there's only 2 ways. Or we can use it so the derivative way is done on page 14. Page 14. Have a look. And the other way is done on page 10. Alright, actually 2 ways. And then if you go to page 10, you'll see the rest of the proof. Okay? Alright. After this, so another thing you need to know that these things actually tell you these are odd functions. Now, if you quickly go back to the graph, you'll see that the function for sine inverse is odd function, and this is odd function. Whereas the cos inverse is neither odd or even. Okay, this is neither. Okay, so we did that. What else are there? So these are the things. These are the identity that will tell us about the graph. And then we have these exact values, which I will recommend you to memorize. If not, then you need to know how to do it with the calculator. But if you memorize them, that will help you in the long term. So sine inverse of 1 is pi on 2. Now, using this rule, sine inverse of a negative becomes negative sine. So if I know this is pi on 2, I know that must be negative pi on 2. Using the symmetry of odd functions, right? So sine inverse of 1 is pi on 2. With an extra minus, you just put a minus there with the same values. Right, sine inverse of 0 is 0. Okay. Same thing for this. Sine inverse of half is 30 degrees, so pi over 6. If it's negative half, it's negative pi over 6. Just remember, it's an odd. Okay. And then, so basically, if you know one, the other one is, you will know that as well. Just put an extra minus. This is pi over 3, negative pi over 3. This one will be pi on 4. This will be negative pi on 4. So it's quite convenient. Okay, good. Next, we're going to continue. Cos inverse of 1. So these 3 points are the endpoints of the graph. So cos inverse of 1 is 0. Cos inverse of negative 1 is pi. And the cos inverse of 0 pi on 2. Okay. So this is neither even or odd, so you can't use any symmetry. So you have to. So let's calculate this first row. Half is 60 degrees, so pi over 3. This is pi over 6, 30, and this is pi over 4. Like that. With the negative, just remember this is in the second quadrant. Second quadrant. So basically, you can just use this formula, right? Pi minus. So you can use the formula. Just go pi minus, pi minus, pi minus, and you can work out this pi minus pi on 3, 2 pi over 3. And then the other one, which is pi minus pi over 6, which is 5 pi on 6. Or you can, the next one is pi minus pi over 4, which is 3 pi over 4. Right, so you get that. So they are done like that. Okay, and then you got the tan inverse, which you should fill out. Okay, we're finishing very soon. That's good. All right, how about the tan inverse? These are the asymptote. So tan inverse of positive infinity as x goes to infinity. Oops, wrong page. One back twice. When x goes to infinity, it goes to power on 2. When x goes to negative infinity, it goes to negative power on 2. So that will inform us that this is going to be pi over 2 here, but negative power on 2 and 0. That. And like sine inverse, it's an odd function. So tan inverse 1 is power on 4. The negative gives you negative power on 4. So if you know one, the other one you will know. It's easy. And same for that one. That's pi over 6. That will be negative pi over 6. This will be pi over 3, negative pi over 3. Like that. Okay, so these are the exact values, and then what else are there? There's the differentiation rules that you need to know. As you know, this is not on the formula sheet, so you need to memorize them. Memorize. Memorize. Okay, now it's quite easy. Just remember the basic ones. And then the other one just has extra derivative of the fx, where this is the fx. Okay. The sine inverse, cos inverse are the same, except there's a minus. They both have square root. And the tan inverse doesn't have a square root. It's a 1 plus. Okay, note the difference between them. Alright, after we do this, then we can have some integration rules. Let's look at the integration rules. So you have these questions. That's on the formula sheet, on reference. But you need to know how to use it. Remember, that one you get sine inverse. This one you get tan inverse with an extra 1 over a in front. And be careful that to use this formula, it has to be in this exact form. So for example, if you have a 25 in front of x squared, make sure you take the 25 out. Do it like this. And then you can proceed to use the formula for tan inverse. Then you can use this formula, okay? So how do we use the formula? So what you do is you have to find a. In this case, a equals to 1/5. That's your a. Okay, that's a squared. And then using the formula, you get 1 over 25 multiplied by 1 over 1 over a, tan inverse of x over 1 over a plus c. And then you can cancel that 5 with this 5, so you get a 5 left over. So you end up with 1 over 5 tan inverse of 5x. Because you divide x by 1/5, you get 5x. Plus c. That's done. Alright, what else are there? And then you should try the other one. The other one's a little bit harder. We have a square root. Have a try. Okay, good. Have a try this. Have a try. Alright, take the 9 out, but just be careful with the square root. So take 9 out, so you get 1 over square root 9. Just put open bracket, 1 over 9 minus x squared. The x, take the 1 over 9 out, so you get 1 over square root of 9. Integral like this. 1 over 3 squared minus x squared. So put it in that special form. Once you have that form, you can work this out. Square root of 9 is 3 times by sine inverse. Sine inverse, there's no extra bit in front of the sine inverse, over 1/3 plus c. Okay, once you do that, it becomes 3x. So you get 1/3 sine inverse of 3x plus c. Alright, done. Okay, what else are there? I think that's all. And then we'll look at some areas. So we'll know how to differentiate, how to integrate. Then we'll look at area. Okay, let's look at the area. Area bounded by the inverse trig function. We did that on page, what page did we do? We did that on page 17, so just refer to page 17. So this is what you do. It's very easy. So all you have to do is to work out the area bounded by the y-axis. So if that's A, that's B. So you do. So the green bit is equal to the rectangle minus the area bounded by the y-axis, and this is important because this can be calculated by using x dy from 0 to b. This is just equal to AB, right? Area of the rectangle. X dy, you just get sine y, okay? Like that. So that's the, which you can integrate. And this idea has been discussed in exponential and log as well. So you can think of log as inverse exponential, just like we have inverse trig. And you do the same method as well. So you do the area bounded by the y-axis. So and then you draw a box around it. So you get the green bit equals to the box minus this bit, which is bounded by the y-axis. So that's x dy. So you don't have to integrate the log, becomes e to the power y dy. Okay? So similar ideas. They are similar. Okay, so we get these ideas. Okay, what else are there? So we know how. Actually, I forgot to mention. So this is ln x. This is sine inverse of x. Okay. Alright, done. And on the next page, there's lots of integral you could try to integrate. Do that by yourself. See how many you can get right. We'll go through in about 5 minutes. Give you 5 minutes to do, or even more, on the next page. So on the next page, you will see all the formula. That's all the integration formula on the formula sheet. See if you can know which one is which. They all look the same. They all have fractions, but not all fractions are one particular formula. They all involve different formulas. See if you can identify them. Okay, have a try. Okay, good. All right, let's go to the next page. So you see all the formulas. So these are formula from the TUNIT reference sheet, and these are just only 2 integral on the extension 1 formula sheet. So all your integration formula are now complete. So only 2 formulas on the extension 1, and then these 6 are on your TUNIT. Okay. Now, obviously, none of these will use these, right? Actually, I shouldn't put a cross. So you don't really need to look at this because this is giveaway, isn't it? Because all of these that are fractions doesn't involve sine and cos, so you won't be using these. And definitely won't be using the exponential. What's difficult is that some of it is this, some of it is this, some of it is this. And they could look similar. And you need to be very careful. Now let's look at the first one. Which one of the 4i, just draw a box around, is the correct formula to integrate this? Now obviously it can't be these two, isn't it? You have a square root. The bottom one doesn't have that, so it can't be inverse sine or inverse cos. And now it becomes these two. Which formula would it be? The top one. Okay, let's use the top one. So you get 1 minus x to the power negative 2 which is the top one, isn't it? So use the top one to integrate 1 minus x to the power negative 1 over negative 1. Make sure you times by another negative 1 plus c. Right? And the negative 1 get cancelled, you end up getting 1 over 1 minus x plus c. Okay? Alright, see if you can do another one. Alright, try another one. I need to record. Okay, alright. How about this second one? Which one would it be? Tan inverse. Well, it looks like tan inverse. You got a squared plus x squared at the bottom. You got the same denominator, but the numerator has an x on it. Now, with the x, you can't take the x out. You can take the number out, but never the x out. So it's actually not tan inverse, even though it looks like it. Which one will it be, Mitchell? ln. Yeah. So you see the bottom is the numerator is a derivative of the denominator. So you can see that this is f dash over fx, which is equal to ln 1 plus x squared plus c. So you need to know the differences and similarity between them. Be careful. All right, let's continue. How about this one? That will be the tan inverse. Okay, so just a slight change gives you a completely different formula. So note the difference. Okay, so these two are very different. However, if I have a 2 in front, if I have this question, it will still be 2 tan inverse, right? But if I have an x there, it has to be ln, okay? But if you have a 2, it's still tan inverse. So if I have an x like this, you just get half of ln. So once you have an x, it's completely different. Okay, what else out there? How about 1 over x squared? 1 over x squared, which formula? Yeah, you just write it in index form. X power negative 2, which is x power negative 1 on negative 1, which is negative 1 over x. Alright, we're going around the worksheet. Okay, how about the next one? X over 2. Is that ln? What would it be? It's just normal stuff. You can take the half out, and you get half x squared over 2. So x squared over 4. Okay, so when it's a constant in the denominator, just take it out, you just get normal. Alright, how about the last one? Is that doing this? Can we do this? X power negative 1 dx. What will happen? You get x power 0 over 0. What's that equal to? Is that 0? Yeah, so when you get this sort of thing, when you have a 0 in the denominator, you have to use ln. So it's like f dash of x over fx. So this is ln x. Note the difference. See, that's x squared. Use this method, but that's 1 over x. It's ln. And when you have x over 2, it's different again. Right, moving on. Try the next one. Try this. 1 over 1 minus x. What do? Do you do this? Would it work? Yeah, every time you have a negative 1, doesn't work because you get 0 in the denominator. So what you do is, you check whether it's a ln. So what do? You differentiate the bottom. When you differentiate the bottom, what do you get? Minus 1. So you put a minus 1 minus on the outside. So you get negative ln of 1 minus x. Yeah. No. It has to be exactly tan inverse. Has to be exactly this. If I don't have an x squared, it doesn't work. So you have to have an x squared. It has to have a plus. If it's a minus, it doesn't work as well. Yeah. All right. Next one. How about this one? What's that equal to? Do this. 1 minus x squared power negative half. It doesn't work, right? So you have to use sine inverse. So let's get rid of this. Sine inverse. Sine inverse of x plus c. Okay, and then how about this one? How about this one? Do you use sine inverse as well? Do you do sine inverse square root of x? You can't do that. So what do? You write that as 1 minus x power negative half and proceed to use this formula. Okay? which is 1 minus x power of half over half times by negative 1 plus c, and the answer will be negative 2 square root of 1 minus x. So they all look very similar, but they can be very different. So I'll put it all on whole page. Yeah. Okay, that gives you a sort of summary. And today you do the chapter review, chapter 7 review from the Maths in Focus textbook, because that has a revision exercise. I will just stop recording.